Welcome back. I hope that you are doing well, and I hope that you are having a wonderful day. Happy Monday, and welcome back from your spring break. Also, hoping and wishing for you, I've kind of put our slide this week, of course, since we're in weather, I've got to do something weather related. And this is kind of my hope for how your day is starting out, how your week is starting out. Beautiful blue skies, sunny, clear weather, and just something, to kind of help us put a positive frame of mind on and kick off our fourth quarter. Can you believe it's April? Can you believe we're finally here in the fourth quarter? This is amazing, guys. We're on the home stretch. I hope again that you had a wonderful spring break. I'm very curious to know how your spring break went and what did you do. We had a really nice spring break. It was great to just get to take some time off and not be on such a, we run a fairly rigid schedule. So we had a really nice time and really enjoyed the time to relax. So we're ready to, jump back in and pick up where we left off with our global weather patterns. And, we've been studying weather over the last several weeks. We started looking at, well, how does heat move around from one place to another? Then we looked at the water cycle and kind of saw how water moves from place to place between our Earth and atmosphere. And then we added on layers of the atmosphere and saw that most of our weather happens in this lowest layer, the troposphere. Now we're going to really start putting all of this together when we look at global weather patterns. So what I'm going to have you do, we're going to keep on logging the weather because I think that we get to see valuable patterns emerge here. So we're on row 8. This is slide 3 in your digital notebook. And then this week, you're going to need to copy over. Here is your template. And so you're going to copy over slides 29 through 35. And then this week, I'm also going to have you take certain snips of different slides and paste them in a Google Doc that I have for you in Schoology. This will be found in your 3.8 folder. So that will be under Unit 3. As always, I have office hours available to you. There is ample time for you to come and get help, ask questions, check in, let me know how you're doing. If you have something going on that's making it difficult for you to get work completed, or you just need, to let me know what's going on, this would be a great time to show up. I take you guys individually. So if you don't like, having to be with a group of people, come to office hours, get your one-on-one help. My office hours will be on purple days during block 2, and that will be from 10 to 11:30 a.m. So there's a really good chunk of time every purple day to come and get help if you need it. Now, looking forward here, let's go ahead and go to our notebook. And let me just make sure I have told you everything I need to tell you so far. I think we're good. Okay, so moving on. Wanted to give you the lay of the land in your notebook this week. So we started looking at wind before we left for break. There we go. And so now we're going to start, adding on to this. Some of this will be similar to what we did before break. Some of this will be new. But we're looking at what causes global weather patterns and how do global weather patterns interact. So we want to be able to understand that because the Earth is heated unevenly, there are certain places that get more direct light than others. That is going to have an effect on our global weather patterns. And when we talk about that, we're talking about wind patterns and ocean currents that are happening on a global scale. Everything is interconnected on our Earth. And I have another beautiful website for you to check out. This first slide, I'm actually going to have to zoom out a little bit. This first slide is a little bit of a refresher of where we were at previously before break. We started looking at what is wind and what is the driver of wind. And we learned that wind is the horizontal movement of air in our atmosphere. And this happens because there is uneven heating on Earth's surface, meaning that at these equatorial regions, okay, at about 0 degrees latitude around the equator, 0 to 30 degrees north and south, we have a lot of direct light coming from the sun. And as a result, this area of Earth heats up more than these higher latitudes and like the poles, like the North Pole and the South Pole. So we have very cold temperatures at the poles, and then we have quite warm temperatures at the equator. And because of this, we will see movement of air and water because of this temperature differential. So we also talked about in our previous week too, how these winds and ocean currents take on these curved patterns. And this is due to something called the Coriolis effect. If you are completely lost and have no idea what I'm talking about, then I really need you to go back up to slide 20. And if you haven't finished filling out your wind notes, then you need to do this. But I need you to watch this little video here that shows you why the Coriolis effect takes place, like why wind and water currents can't just move in a straight line. And this will also, here at the bottom of slide 20, will also be a nice little help and clue for you if you need it down here, because you're going to take these arrows here and you're going to put one over the southern hemisphere and you're going to put one over the northern hemisphere based on the direction that these convection cycles go. Okay, so refer to your notes on slide 20 if needed for that. You also can get an idea based on this little picture right here. Okay, so you'll be putting those little arrows on. Next slide. Now we're going to, we talked about wind patterns some. Now we're going to kind of start putting this together. And wind and water, like surface currents, follow very similar patterns. And that's, partly due to the fact that wind is pushing against the surface of water in our oceans. And so these patterns that they take on are very similar. So short video for you to watch here. I want you to pull out about 5 facts from this video and build some notes off of that. Then you've got this map, and I want you to make 3 observations about what you notice about the arrows in this image. Okay, and you've got a key here letting you know what these red arrows symbolize and what these blue arrows symbolize. So, and this should make sense, okay? When we think about uneven heating of the earth, these red arrows symbolize warm temperatures. These blue arrows symbolize cold temperatures. Okay, so make some observations for me, and I'm curious to see what you notice. This will be a slide that you will be snipping and putting into the Google Doc that I have for you in Schoology. And this is how you're going to be earning part of your participation points this week. On slide 32, I have a short review of seasons. Now, this is not something new, but this definitely ties into global weather patterns. So I wanted to give you a quick refresher on seasons. So I have another short video clip for you asking you to add another fact. So I've got some facts here for you to read and then add on to. And then you're going to drag these labels over the diagram to show me winter, summer, spring, and fall according to what you see happening in this diagram. And I want you to label this according to, think about, like your place in the northern hemisphere. Okay, so when the northern hemisphere, again, we've got our Earth sitting at a 23.5 degree tilt, hence uneven heating of Earth's surface. So here at the equatorial regions, we have a lot of direct sunlight. Over here, as we move toward the poles, the energy from the sun is spread out over a larger area, which gives us colder temperatures. So that, again, that temperature difference that we see is actually due to our tilt of the Earth, and this is also going to impact seasons. So when the northern hemisphere is tilted toward the sun, I want you to label what season we'll see here. And then we move through when the northern hemisphere is tilted away from the sun. What season is that? And you should be able to fill that out, that label that diagram with the information in the video. Okay, so that's slide 32. Now we want to begin to connect with, these global weather patterns that we see. We need to delineate the difference between weather versus climate. Our weather is what's happening on a daily basis. So I'm telling you, hey, go in and log your weather. Let's see what's happening. And, we can, I think, really get a good grasp on weather versus climate because where we live in the Midwest, we have changes to our weather almost daily. Some days it's rainy, some days it's cold, some days it's warm, some days it's sunny. So our weather can change day to day. But this is very different from climate. And climate has to do with your latitude. Where are you at, in terms of how the sun is heating up the earth? What are the overall, we can think of this as like yearly patterns, like what kinds of seasons do you have? What is your typical rainfall in a year? What are your average temperatures? So it's kind of looking at like the long-term story. So I want you to watch this video that goes over, and gives you a lot of great examples of weather versus climate. And then I want you to fill out this Venn diagram describing characteristics of weather, like what do we need to keep in mind for weather? What do we need to keep in mind for climate? And then what are some commonalities that they have? In the study of weather and the study of climate, we're going to use a lot of the same type of information. So that would be something that you would want to think about here in this middle section. And I really don't want to give it away. I really want you to go in and watch this video and then build your own notes and add your own information. But I will be looking for some commonalities here. Okay, so that gives you your introduction of weather versus climate. And then this slide on 34 is just going to help you explore climate just a little bit more. Oh, you know what? Darn. I forgot to show you something. Okay, backtrack. Honorable mention here on slide 30. I have another beautiful website for you guys to check out to help you see what's going on in real time with all kinds of things related to weather. So if you click on this link, I love this. I think this is so beautiful. Look at our amazing Earth. And right here, if you go down to the bottom left-hand corner and click on this, you have all of these different things that you can manipulate. So like right now, this view, when you open the sky up, is going to show you wind currents that are happening at the surface of our planet. There's a scale here, and if you look down here in the bottom right-hand corner while I scroll over the scale shows you what these colors mean in terms of wind speed. So there are certain places on Earth where wind is moving faster and certain places where wind is moving slower. Be great to check that out, make some observations. And then you've got all kinds of things that you can play around with here. So you could look at like air currents, like wind, or we could look at ocean specifically. And we could look at like waves or ocean currents. And then you can look at like, I'll go to that in a second, but you can basically play around with different modes here. So for instance, let's say I wanted to look at these wind currents that are going on, but I want to see what the temperature is like. So you can actually change the background there and look at temperature. And now the scale is actually going to show you what's going on globally in terms of where things are at in degrees Celsius. This is all wonderful to connect, uneven heating of Earth's surface and to really see the Coriolis effect in action. And I would just kind of encourage you to take some time to explore and look around and see what all of this means. You can drag this thing around and look at all areas of the globe so you can see like, oh man, we are rocking right around the equator some really hot temperatures. My goodness. And as we go up here to the north, we're rocking some really cold temperatures. In the Northwest United States, ooh, look at that cold polar weather. And it would be really interesting to see where the jet stream is in all of this. But we're going to come back to this, guys. So I would encourage you to play around and check this out. I just love this. I think it's such a nice visual. And you can really see with interactive maps like these, everything on Earth is interconnected. Everything is tied together. And we see that we are all connected here globally in terms of how wind is moving, how waves are moving. And you can all, and so we're all just interconnected. This is a global system. And so, what impacts us is also eventually going to have an impact all the way over somewhere, like in China. So nobody lives in isolation here. We're all connected globally in this amazing system of Earth. One thing interesting to point out here is that you'll see at these equatorial regions, the winds are not as strong, are not moving quite as quickly. Whereas look over here, as you go into where we start to see these temperature differences, look at how these winds swirl around and they're moving more quickly, stronger. And so the more difference that we have in temperature and the greater the differences in air pressures, the faster wind will move. So I just think this is wonderful resource for you guys. I hope you like this and we'll take the time to check it out. Okay, enough of me waxing poetic about the Earth. Okay, so anyway, start checking out these different climate zones. We will often refer to these as biomes, and we'll come back and we'll be doing more with this later on. Last thing I have for you is a graph analyzing climate data. Now, I'm not giving you a ton here about climate change or anything like that, but I do want you to check out this graph and make some observations. So check out, this is degrees Celsius. So temperature change in degrees Celsius. And then this is along here, the x-axis years. Okay, so this is 1880, 1890, 1900, and then we're going all the way up to 2010. So we have, on this graph, we have some data here. We've got global land temperatures. So we've taken temperature data specifically from land. We've taken, and that's the kind of brownish gray line. We have taken temperature data from the ocean. So that's the blue line. And then we've kind of combined that set to look at the average globally. So I'd like you to check this out, thinking about each decade, what might be going on in that decade, and then looking at the graph and looking at what's been happening to temperature in terms of shifts and changes. So give me two claims, or give me at least one claim and provide evidence from this graph to support it. That will take you through your lesson, like basically just kind of looking at different global weather factors and starting to look at climate versus weather. Over in Schoology, which I've got to go to a different tab here, where this is going to come into play here is in Schoology. Our folder this week is 3.8 global weather patterns. And you're going to be taking your SNPs. There is an assignment here called Global Weather Patterns Lesson. Open this Google Doc. And I'm asking you, here are the SNPs of the slides that you're going to take. So snip it, paste it in this document, and then submit in Schoology, and you are done for the week. That's going to be it. So I am excited to look at your feedback and see what you've got going on for in your notebook this week and what connections you have been making. So for me, down in the comments of our discussion for this weekly overview video, I would love to know on a non-school related topic, what did you do over spring break and what was that like for you? And then I also would like to know, what are you looking forward to in the fourth quarter? Um, you know, are there any activities that you've got going on that you're excited about? Are you looking forward to a fresh start? Just kind of let me know, what are you looking forward to in this quarter? And also, please let me know how I can support you, how I can be of assistance to you and help you just make this quarter as successful as possible. Okay. I've talked for a long time, so it's time for me to go and let you guys get to it. Thank you so much for taking time out of your day to see what we've got going on in science this week. And I hope to talk to you soon at office hours. I'll talk to you later. Bye.